Hey everyone, in this tutorial we're going to be building an AI spawner that can spawn pawns on any surface around the spawner in 360 degrees or in a sphere to be used with the Dynamic Surface Navigation plugin. If you're already well versed in Unreal Engine and line tracing and all that stuff, this tutorial may not help you too much. But if you're not, I think this tutorial would be helpful for you if you plan on using the Dynamic Surface Navigation plugin. Alright, let's start by creating the actor for our spawner. Let me blueprint class, let's select actor there, and we're going to name it BP_spawner. Save that, and let's get into it. And now we're going to add a surface nav invoker. This will make sure there's always navigation with the Dynamic Surface Navigation plugin. So you'll need to have that plugin enabled to be able to access this component. It's just Dynamic Surface Navigation right there. Make sure that's enabled. So we'll add that component, Surface Nav Invoker, and we'll just leave the defaults for now. The next thing we want to add is just some visual representation for this actor, and just to be a sphere, basic sphere. And we want to come in here and disable all of the collision on it, because we don't want it to be to have collision, or otherwise it'll get navigation generated on it. See, no collision, and I'm also going to make sure can ever affect navigation is turned off. And I'm just going to apply a different material, checker material, just to make it stand out. And also, I'm going to make sure it's hidden when we play the game, hidden in game. Let's see, next I'm going to add something to represent the spawn area, visually represent the spawn area. That's just going to be a sphere collision. And I'm just going to rename that to spawn area. And I want to give it a higher default value just so I can see it. We also want to turn off collision on this because we don't want the collision, we just want the visual representation of the spawn area. Collision, navigation, we want to turn that off as well. Okay, so now we're going to create a couple of variables to be used in the construction script. So let's create one. This is going to be spawn radius, and that's going to be a float. And we want that to be visible as a parameter. And then the next one's going to be spawn interval. We also want that one to be a float and also visible. We'll give spawn radius, let's compile that. We'll give spawn radius default value of 500, and spawn interval a default value of 5. Now we're going to get our spawn area here and set sphere radius. Set that to spawn radius. Next, we're going to set the actor's tick. It's tick interval. And use spawn interval. So now that we've got that set up, I'm going to compile it and go to the viewport. So you'll see now our spawn area is using the radius that we set. So when we change this in the level as a parameter, it's going to change our spawn area with the visual representation of how far out it's going. Now let's switch over to our event graph here, and we're going to only care about the tick for our purposes in this tutorial. What we want to do is create some variables to track how many are being spawned in, and so we can set a maximum on that as well. So we're going to want two more variables here, and one of them is going to be current pawn count, which is going to be an integer, and we don't need to make that one visible, so you can just keep the little I closed. Next one is going to be max pawn count, also an integer, but we want this one to be visible as a parameter, so we can set it from the level. And then we want to go ahead and give it a default as well. We'll just give it a default of 10. Alright, since we're going to be using tick as the spawn interval, I'm going to do a little if statement, or branch off of that, and then the condition for that is going to be to make sure current pawn count is less than max pawn count. Now the next part we need to actually find an available spawn location. So I'm going to create a function for that. We're actually just going to name it find available spawn location. And in this function, what we're going to be doing is a line trace and a random vector direction, and then also a sphere overlap test at that location to make sure there's no pawns within a certain vicinity. And we're going to need another variable here, and this one is going to be min spawn distance from other pawns, and this will be a float. And we'll want to make it visible so it's configurable. And this one I'm just going to default to 100. Alright, and to start we need to get the actor location, a random unit vector, and then we're going to also need our spawn radius. We're going to multiply random unit vector by our spawn radius, add that to our actor location. We're going to use that to do a line trace profile here. We want the start to be our spawner, so actor location, and the end is going to be this little calculation we just did to find the endpoint we want. And also on this line trace, we don't want to be hitting any pawns, so I'm just going to be doing ignore only I believe it's what it's called. So that way, any hits we get, not going to be a pawn. Next, we're going to do a branch to see if it was successful, if we got a hit or not. If we did not, go ahead and return. And that reminds me, for this function, we need to return 2 parameters here. So we want a success as a bool and an out spawn location. This one's going to be a vector. And for this return, since it failed, we're not success is false, we're not returning any vector. Now if it's true, if we did get a hit, we want to do a sphere overlap actors, and we're doing this so we can prevent 2 pawns from spawning in too close to each other. And we're going to use that min spawn distance from other pawns as the radius. We're going to I need to correct this. This is not supposed to be a multi-line trace. So it's just supposed to be a line trace. Copy all those values over. So we need to break this out, the hit result, because we want the location, the hit, to be our position for the sphere overlap. Clean that up a little bit. Now for our object types, we're going to make array and drag that array to the object types and select pawn there. So we're looking for any pawns within the distance we specified. Alright, so now we want to see if we had any hits. We're going to actually do a not boolean to flip it for doing the branch. So if we did get a hit, since we have the not, if we did get a hit, we're going to return, because we don't want to spawn anything if it found a pawn within that distance. But if we did not get any overlaps, we want to return success. And the value we want to return, we actually need to come back here to that original hit we got. Drag it over here. We're going to break it again. Break it out. And use that same location as the return vector. Alright, let's compile that, make sure we got it right. Good. Oh, and I almost forgot, we got to come back here and use our new function. Call that if this is true. And we're going to have this branch here, if it was successful or not, which is going to lead us into the next step. Now we're going to create another function. This one is going to be find rotation for location. And this function is going to take in a parameter in spawn location, which is a vector. going to return success as a boolean, and also return out spawn rotation. And this one is going to be a rotator. Now before I forget, let's go ahead and add the call to this new function. We're going to use the spawn location from here, put in the end spawn location for find rotation for location. And so what we're going to do in this function is we don't want to just use the hit point that we got with that line trace. We don't want to just use its normal to determine a rotation, because we could attempt to do that and use the normal as the up value for the pawn's rotation. The problem with that is if that hit was, say, on the side of a rock, a small rock, well, you may be spawning your pawn in sideways on flat ground that just happened to hit the side of a rock. And so what we're going to do a couple of other line traces and use those other hit points to build a rotator with a forward and a right unit vector. And so let's do that now. We're going to need some local variables for this function. Spawn unit direction, and this is going to be a vector. Do test direction 1, also a vector. Test direction 2. Forward and right. You'll see how we're going to use those in a moment. Okay, let's just pull this over here. We don't need it right now. And let's calculate the value for the spawn unit direction. I'm going to use get actor location. And then spawn location, which is just our input variable, input parameter for this function. And we're going to use those two to get a unit direction. So we have that unit direction. We can store it in spawn unit direction. Okay, so let's take this spawn unit direction now that we just calculated. We are going to make rot from X. And we want to break this out. Break rot into X's. And this is going to help us determine what the end point is going to be for the line trace, for the other two line traces. And we need to create another variable. It's going to be find rotation test distance, and this is going to be the float. And we want this one to be visible as well, so it can be configurable. First, we're going to take the y from the rotation that we broke apart and multiply it by our find rotation test distance. Also, let's go ahead and give this variable a default value before we forget. And we're going to take our spawn location in spawn location and add it together with the value we're calculating right there. Vector. Now we want to get the actor spawn, or sorry, actor location. And we're going to unit direction from the actor location to this new vector that we have. Take that and set it. Use that as the value. Whoops. For test direction 1. Now, this all is pretty much the same for the next step. Except we're going to be using Z. And for this one, we're going to set test direction 2. Okay, and from here, we're going to do our first line trace. Make sure to do a single line trace, not multi this time. Trace. And we want this to be ignore only pawn again. And we're going to get actor location. That for start to get our test direction 1 and our spawn radius. Multiply those together. And then add the actor location and this new vector to get the end for the line trace. I'm going to do a branch. If we don't get a hit, we don't want to continue. We're just going to return. But if we do get a hit, we want to break our hit result. And we need our in spawn location again. Because we're going to use this to get the unit direction from our original hit location to this new hit location. And that will be our value for our right vector. Now, since a lot of this is going to be the same, I'm just going to duplicate it over here. We're going to have to change out some values since I copied it. So we're going to change this one from test direction 1 to test direction 2. And then change this set from right to forward. And last bit is we need to return with successful because we got a rotation. We're going to make rot from X and Y. So the X is going to be the forward, Y is going to be right. And so now we have our rotation. Take a quick look here, make sure got everything. I think I do. Let's compile. Save that. And back to our event graph. We've already got this. Okay, we already added the function call for find rotation for location. We're going to do if right here. Before we create the last function, let's create a new event over here. Call this custom event. I'm going to call this pawn destroyed. And we want to add an input to this. Call it destroyed pawn. If I can spell destroyed pawn. I'm going to make this an actor. Just like that. And when this is called, we're to take our current pawn count and subtract 1 from it. Just like that. And you'll see how we use this later when we're setting up the function. And our last function is going to be spawn actor. We're on the home stretch now. So this is going to be in spawn location vector. And then another parameter in spawn rotation. It's going to be a rotator. Alright, so we're going to spawn actor from class right here. We don't want to be hard coding the type of actor we're going to be using. So let's create another variable, global variable. We're going to be actor type. This to be actor class reference. And we want to make this visible as a parameter, so it's configurable. So we're going to get this actor type and plug it in there. I'm going to go ahead and make this always spawn, ignore collisions for the collision handling override. Now we need to build the transform. Let's do that. We need in spawn rotation. And from this we're going to get up vector. And for this part we are actually going to need another variable. It's going to be spawn offset. Basically, how far are we going to offset it from the ground or whatever surface it hit. It's going to be a float. I'm going to use this here, and we want to also make spawn offset visible. So we want to multiply these two values together, get a new vector, take our in spawn location, add these two together, and spawn rotation once again. We're going to make a transform. Location and that rotation. Okay, so what we're doing here, we're getting our rotation, the up vector from the rotation, and multiplying it by our offset, and that's giving us, turning our float offset into a vector offset. And so now we've got a vector offset. We can add that to our spawn location, which will pull it away from the surface a bit, and then make our transform from that information. And something I'm just doing for this tutorial to make it easy and prevent it from getting cluttered up is I'm setting a lifespan on the newly spawned actor, and I'm just setting it to 30 seconds. So they'll be destroyed after 30 seconds. And next I want to bind to that event we set up earlier. So we're going to bind to on destroyed, I believe. Yep, bind event to on destroyed. And here we're going to call create event, which will allow us, once we hook this up, to select the event we created earlier called pawn destroyed. So now, whenever our pawn, the lifespan hits 30 seconds and it gets destroyed, our event that we set up is going to get called and subtract 1 from that current pawn count. Speaking of the current pawn count, now that we've gotten this new actor spawned in, we need to adjust it by increasing it by 1. So we've got this function created. Now we can add the call to spawn using our rotation and our location. Now that we've got the spawner created, let's get it in our level. And so we've got it out in the level. Let me just move it out a little more there. And you can see the spawn radius is indicated by that sphere collision we put in there. And so if we come down here, we're going to increase that spawn radius to, let's just double it, see how that looks. Not quite covering everything. Let's see. Almost. Let's make it a little bigger. Let's do 1100. I think that's okay. We'll leave it like that. And spawn interval, I'm going to drop this down to 1 just so we get more spawns. Max spawn count, let's do 20. We need to set the actor type, which is going to be the spider, the demo spider. Offset, I want the offset from the spawn point to be 30. So it'll actually spawn 30 units away from the surface. And I think everything else looks okay. Let's go ahead and try it out. And it seems to be working. Spawning on all the surfaces. Could maybe use a little larger offset, but that's easy enough to do. But otherwise, looking pretty good. Okay, so that was the tutorial to build a spawner for the Dynamic Surface Navigation plugin to spawn pawns on all surfaces. I hope you enjoyed it. Sorry it's a bit longer than I originally planned. I cut things out and sped things up where I could. But if you did enjoy it, please like the video and subscribe if you'd like to get notified of future videos. Have a good one.